Hi there, students. It's Ms. Zhang. I am at the girls' individual sections tournament today for tennis, so I can't be here with you today, but I thought I'd record this video so that we can go through the notes together, and hopefully you'll be okay with that. We'll go over any questions you have tomorrow. So if you haven't downloaded the notes yet, you might want to pause the video right here and go ahead and download those notes right now, and we'll get started.
All right, so last week you guys explored some different angle types on GeoGebra. Today we're going to go through those vocab words and talk about what they mean, just so that everybody's kind of on the same page. So we're going to start with the word supplementary. Here's supplementary. Supplementary, hopefully you guys kind of figured out last time that it means that there are two angles that add up to 180 degrees. Two angles that add up to 180 degrees. And just some quick notes about that. They can be connected like this, but they don't have to be connected. So I'm going to write that they can be connected or not connected. Doesn't really matter if they're connected or not. All that matters is that they add up to 180 degrees. Okay. The next one is complementary. And through that investigation, hopefully you guys figured out that complementary means that they are two angles that add up to 90 degrees. And one other picture that's not drawn here is maybe something that looks like this with the 90-degree angle in the corner, where it's maybe like we don't even know the degrees of A and B, but we do know that they add up to 90 because of that 90-degree angle in the corner. So if you ever see that 90-degree angle, it means that they're going to be complementary. As long as it's two angles that are split in there. And again, the same thing as before, it can be connected or not connected. They don't have to be connected, but they could be connected. So, they don't have to be connected. All that matters is they have to add up to 90 degrees. All right, next one, vertical. Vertical angles are two angles across from each other formed by intersecting lines. Formed by intersecting lines. So if you look over here in the picture, our intersecting lines mean that there are two lines that are intersecting, and that's the angles that are across from each other like this. The one thing that's going to try and throw you off is something maybe like this, where we have a line like this and then it kind of bends. Don't be tricked into believing that this angle right here and this angle right here are vertical, because they're not formed by two intersecting lines. This line right here bends. So like it's not an intersecting line, it's two segments that are meeting at the line. So that's the one thing you have to be careful of with vertical angles. Actually, I'll leave that. And then hopefully what we kind of learned through the investigation was that vertical angles are always congruent. Okay, so the next word is adjacent, and we actually didn't talk about that in the investigation because it's pretty basic. It just means two angles that are next to each other, but I'm going to use the more technical definition, so I'm going to say it's two angles that share a common vertex and side. So if you look over here in the picture, the common vertex, remember that vertex is that's really hard to see. The vertex is the point where the angle turns or bends. So they have the same vertex, and they have a side that they're sharing. They both share that common side. So that another way to think about it is they're just next to each other. Okay. I don't think I have anything in particular to put in the notes for that. And so let's move on to linear. Linear, guys, we also call it a linear pair. So if you ever hear me say linear pair, it's the same thing as linear. The linear angles are two angles that are adjacent and make a straight line. Which makes sense. Line, linear, has the word line in it. So it's helping you remember. One thing I will often do, guys, with linear pairs, I will show you that it's a linear pair using this half circle. Because if you remember, a whole circle has 360 degrees, a half circle has 180 degrees. And so that helps us to remember that linear pairs are, that's right, linear pairs are going to be supplementary. So they're always supplementary. And they have to be adjacent, so I think I already put that in the definition though. So one of the biggest things you're going to see is like something that's going to try and fool you into being a linear pair is something like this. Like these two angles right here. They look like they might be a linear pair because they do make a straight line, but if you look really closely, they're not adjacent to each other. So they can't be a linear pair. They're not next to each other. They can't be a linear pair. Linear pairs have to be next to each other. So it's like, if you think of it as a half circle split into two parts, that's more like what a linear pair will be. It's a half circle. That's why I like to draw the half circle. You'll see me do that a lot. I think it's a good visual. So just be aware, I'll keep that there. Be aware that these ones are not linear pair. Okay. So let's go through some examples now. So we're here, these examples are saying we need to identify if these are adjacent, linear, vertical, complementary, supplementary, or neither. I haven't really, or neither, because it's possible that they're none of them. Oh gosh, my handwriting is so bad. I'm sorry, guys. Neither. All right, so let's look through one. And just keep in mind that they can have more than one answer. So in this one, we've got angles, y and z. They are right next to each other, so adjacent is good. I just kind of go through these words, like now I'm going to check to see if it's linear. I see a straight line here, which some people might think that this is linear, but remember, y and z together do not make that straight line. They make a bended angle. So it's not going to be linear because y and z don't make that straight line. There's a straight line in the picture, but y and z together do not make that straight line. Vertical, no, there's no way they can be adjacent and vertical. So adjacent and vertical, we can never be both. Complementary means they add up to 90 again, reminder. There's no indication that they do. There's no box to show me, like this one has a box, so that shows me there's a 90-degree angle somewhere. So I'm not going to include that. And then supplementary add up to 180. There's no indication that they do, so I'm going to just leave it at adjacent and call it a day. Okay, number 2. Adjacent, yes, they have a shared side and a shared vertex. Linear, no. I know there's a straight line, but like kind of the similar as the one before. Y and z together do not make that straight line. Y and z together make a bended angle. So it's not linear. Vertical, no, because again, adjacent, vertical, they don't go well together. Complementary is one that I will say yes to because we see that 90-degree angle here. If you see it there, you can also draw it on the other side. It's just that usually you will not see a picture that has two right angles. If it's on this side, you can assume that it's on the other side as well, as long as this is a straight line. So yes, this is complementary. because y and z are going to add up to 90. And if it's complementary, it can't be supplementary, so not supplementary. All right, number 3. We've got intersecting lines. These are across from each other. So right away I know that they're vertical. Anytime they're across from each other, it's kind of like a figure 8. If you can make a figure 8 from straight lines, that's vertical. So if they're vertical, they're not adjacent. They can't be linear because linear has to be adjacent. Complementary, we're not really sure. They could be, but we don't know for sure, so I'm not going to write it. And supplementary, again, they could be, but we don't know. All right, so we're done. And then number 4. All right, we've got y and z. They are not adjacent because they're not right next to each other. Here's angle z, here's angle y. They don't share a common side. Linear, again, this is kind of like that one I showed you guys up here. They make a straight line, but if they're not adjacent, they can't be linear. Because remember, linear has to be adjacent. That's what it says up here. So not linear. They're not vertical. This one looks like maybe it could be vertical, but it's kind of this idea up here that I told you about with the vertical. They have to be formed by straight lines. And so if you look really closely, y is formed by these two intersecting lines. That's how y is formed, but that's not how z is formed. Z is formed by two different lines. So these angles would be vertical, but not y and z together. So it's not vertical. We don't know if it's complementary. We don't know if they add up to 90. We don't know if they add up to 180. So this is actually the neither. Like neither. Neither, neither. I don't know what the right way to say it is. All right. So the last couple examples, I'm going to actually skip number 7 because we're not doing that. So the last couple examples is asking you to identify if they're adjacent, linear, vertical, complementary, or supplementary, and then try and solve for y. So in this one, we know for sure that these are adjacent because they're right next to each other, but it also makes that straight line. So this is the one where I can draw that little half circle and say, ooh, these are linear. They're also adjacent. And if it's linear, remember up here, if it's linear, it is also supplementary. So I'm just abbreviating here. So if we know it's supplementary, that means we know that y plus 50 has to add up to 180. So I'm going to subtract 50 on both sides. I get 130. So y equals 130. Number 6, we've got angles that are across from each other like this. That to me says vertical. And we kind of already talked about it up here. If it's vertical, it's pretty rare that it's going to be anything else. It could be complementary or supplementary, but in this case it's not. But one thing we do know about vertical angles is that they are congruent to each other, which if you remember, that means they're the same. So that means if this one's 43, then this one's 43. And we don't have to do any math, like any calculations. We just have to understand that it's the same. As long as you understand why it's the same. It's the same because they're vertical. All right, so that's the notes for today. I will answer any questions you guys have tomorrow. Other than that, have a great day.